Всем привет. Меня зовут Владислав.
Hello, everyone.
Коллега
My
Юра.
name is Vladislav, and I have Yura with me. We work for Yandex Cloud in cloud security,
Непосредственно
and we deal
так и
with security for the cloud and our clients, and we develop security services.
реализации.
So we will talk about the way we protect
Говорим, как AI
Yandex Cloud and its clients. I will talk about AI finding its way in this field.
То есть Владислав, он
It is funny in a way. Vladislav is an architect, and he develops good features for the SOC.
соответственно,
And
предлагает и
we consider the things he
первые люди, которые
makes for us, and we are the first to test this. You know, we are like failing, and we have some experience in failing well, and we share with him our first feedback. When I joined Yandex Cloud, my first task was to improve the detection tree process. And, you know, clients come and they say what can be done, and sometimes this follows an incident when it's like a terminal stage, as we call it, and they come with the question, how can we give our client more Lego cubes so that they build a good protection system, so that they are happy. With this approach, we generated some statistics, and now we can see how
проникают.
hackers penetrate cloud infrastructures. And the first thing to consider would be that the complexity of cloud infrastructures is growing year on year. Now we have about 200 services in the cloud, and so you should know everything now, like an analyst. You should know how our service is used, because people will come to him asking questions whether they're suspicious or not, and this is really challenging. So you should somehow kind of cope with that. The second issue is the flow of data coming from the service available to the security guys. Now this flow is pretty intensive. We just measured it. It has grown 20% recently for our cloud. You can use it to identify anomalies, to detect things, but you should cope with it somehow. And, well, there are some risks here. We can see kind of first AI-targeted attacks.
По циферкам, вот то, что мы
Some numbers.
самая такая жирная категория, это попытки доступа к
More often than not, they try to get access to the
и понятное дело уязвимости.
information through some leaked secret data, and they also kind of find some vulnerabilities in the infrastructure and attack this. And we also have DDoS attacks. Okay.
ML про AI тебе нужны
Talk about ML and AI, you need some building blocks, and that's what we'll be talking about.
Да, первое, о чем мы расскажем, это
Okay, the first thing we're going to talk about
real-time
will be our real-time
облако, ну и на самом
stock taking of all the assets in the cloud and outside of it. And then we'll share with you how
именно
we use this set of assets to perform our tasks, including configuration and control inside the cloud services. And we will also share with you some real-life examples, how we caught a threat actor using the database of assets.
расскажем, как
And then we'll conclude by telling you how AI helps us in our routine tasks in cloud security.
как бы, наверное, всем известно, что безопасность, она начинается с инвентаризации.
Okay, so we start with stock taking. So the first thing we did
Собирать
was gather information on all the assets we have in the cloud.
на сервер.
This is not like a monolith servers. We have dozens or hundreds of loosely connected
Все
services. All of them have their own understanding of assets. For us, an asset is any
сущность.
entity, important in terms of security. It can be a cloud entity, it can be a client load entity, but now we are focused on the cloud entity.
То для сбора активов, как правило, доступны довольно низкокачественные источники.
We usually have low-quality sources for stock taking. This is about logs and audit information, audit events. So this is,
Не полная
I
информация.
would say, incomplete information.
Основной сценарий внутри сервиса безопасности работы с активами — это
Major scenario
простой
of dealing with the assets,
системы.
well, I would say that this scenario
Это когда
is quite good
посмотреть
for all the
хронологию одного актива,
systems when we want to look at one asset history to see how its features changed in time, but it doesn't cover the needs of most of the security needs. And the most sophisticated
точкового времени,
scenario would be
интервал,
kind of backtracking. So we have some
смотреть, как
point in time, and we want to see,
интересного фильтра.
for instance, all the assets which can be filtered out by some settings we have applied.
Во время сбора активов есть, на самом деле, как бы три основные сложности.
When we do stock taking, I think there are three major issues. So why it's difficult to build a good database
Первое — это то, что
on your assets?
источники данных
Number one, the sources of data
часто предоставляют, они почти всегда предоставляют неполную информацию об атрибутах.
are usually incomplete in terms of the attributes of your assets. So you are not likely to see this condition for the asset which was changed by another condition for a given asset. Usually you'll get something like some specific attribute or a group of attributes of an asset was in this condition and then it changed its condition. And all the other attributes should be kind of received from some other sources. The next problem
Источники,
is that
они имеют такой своеобразный
the data sources, they have their own understanding of real time.
прошлого,
They
например,
can send you some events from the past.
машина сервиса какого-то одна конкретная, например, ушла, и
Say a machine or a machine from a service kind of
они приходят.
goes offline, then it's online again, and it sends you some logs which come with delay in time.
В любых сервисах,
And the most important thing is that all services are
когда источник
prone to mistakes, and quite often the sources provide some wrong data, and then they send some corrections.
Самое, наверное, главное, чем как бы отличается наша база данных, которую мы используем для сервисов безопасности от всех
Our
остальных, это тем, что
security database is different from many other bases because it has a good timeline. So for security,
либо в какие-то конкретные
we are not focused on the last kind of condition. So we need this condition spread throughout time or some time intervals. So the attributes might change in time,
как-то понимать
and we need to understand
в каждой точке во времени, какие
at any moment of time
эти атрибуты.
what these attributes looked like.
Еще одна сложность, с которой мы сталкиваемся при построении хронологии, наверное, самое существенное, это то, что
Another important issue we face is that physical time,
оно
well, sometimes it matches the logical time, but quite often
аномалии, когда
we have anomalies when the physical time
оно полностью не соответствует логическому.
doesn't completely match the logical time. Those who've dealt with modern bases, including the
Две транзакции произошли физически,
distributed databases, so if you know
значит, что
that two transactions happened at the same physical time, it doesn't kind of mean that logically they happened at the same time. And if you collect attributes of the source following the physical time, then your latest change will not be the latest state of the asset. And then you will kind of have a wrong understanding of the attributes for your asset.
Помимо хронологии данных, то есть
Okay, we have the data timeline.
данных внутри атрибутов актива, есть еще одна сложность.
So the data related to the attributes of the assets, we have another problem.
Он тоже меняется во времени.
And the set of attributes, the schemes, they also change in time, and we also should keep track of the versions.
Сценариев, когда
So we have some streamlined scenarios when attributes come and go, but we also have some sophisticated things in terms of some
атрибуты меняются,
scenarios, like when the attributes change the type,
переименовываются.
they move, get renamed, or move to some adjoining
В качестве реализации хронологического
entity.
хранилища мы внутри
Okay,
используем Яндекс Database.
we use our Yandex database. So the overall cloud is built upon the Yandex database, but we understand that for sophisticated scenarios, these classical databases are not good. That's why we use indices which are specialized. They're built on the interval tree inside the Yandex database. So we keep track of the versions using data buffs, and we also
позволяет нам достаточно быстро
store protobufs inside the database. This way we can
активов.
easily get the
То есть это какие-то
time
секунд на, наверное,
information for the assets or elements of the assets.
в принципе, вообще
And so that this would take just fractions of seconds, even for the biggest entities. And the Yandex database also gives us a chance to scale out almost endlessly and almost for free. Okay, so we have a cool system, a lot of code, how to use it. Okay, so if we have this chronological database of assets, it works really well for your investigations. So we considered a specific incident, and well, sometimes, when you force the threat agent out, they just delete things along the way. And you could say, oh, we remember we had some APIs, and what kind of APIs are there? Okay, you would say, but that's it. These machines have been deleted. The APIs are kind of cut loose. And so, okay, then we say, okay, let's try this experimental system. And well, in the SOC, we usually spend hours doing this because you need to find the right logs, you need to understand which machines and the logs you should connect, all of this, and so on. But here you can do it in just fraction of seconds. Okay, we just run the virtual machines and we see what was done by the threat actors. This should be used. This is a good tool for security guys. It works really well. Okay, talking about prevention rather than response. So we could talk about the hygiene of configurations. And as I mentioned, so we have some statistics. So, and they're kind of statistical credentials, and they can be used for a long time. So this is a problem, a general problem for everyone. The second problem, your security guy should know everything. You have millions of layers of services, the same kind of complexity of security, and setting it all properly takes a lot of time and effort. Okay, so if you just look at the assets and you see, okay, the state in real time has changed and it should go back to some proper state, well, this thing can be quite helpful. And if you look at some statistics, Google, for instance, recently published their report for the first half of 2025 on the risks in the clouds, and they say that misconfigs and statistical keys cover 80%. So we would say 70%. So this is more or less a good match. So that's what we see on our radars.
Да, как Юра уже сказал, мы используем ту же самую хронологическую базу.
We use the same chronological database to control the configuration of assets, but we use it in a different way, not how it is done by the kind of classical systems.
По сути,
So
состояние
we describe the condition of good and bad configurations. So we are not driven by some specific events, by the things happening in terms of logs or
по сути,
whatever, which causes incorrect configuration.
состояние целиком
We start with the overall condition, and we say
выглядит вот так. И после этого
that a good configuration of assets looks like that. And then the system
мы знаем
will kind of control
времени,
the things. So we know all the time intervals when the configuration deviated from this good state.
сформулировать, не знаю,
If we try to kind of simulate a test for this, okay, I share with you an example of
состояние проверки, это
easily formulated test.
любой момент времени,
Like at any moment of time, we shouldn't have virtual machines having access at the same time to the internal network and to the internet. So in terms of condition, this is easily formulated. But if you try to analyze the flow of events
при каких
and to see which events with which attributes start violating this or kind of matching these requirements for all the machines inside the organization, then you'll have several dozen events,
как бы понять,
and you should understand how to respond to them, and they'll be emerging continuously. So there'll be new services, new features, and you should keep track of this.
Поэтому мы предлагаем как бы не
That's why
классические
we are not talking about classical CSPMs. We are talking about continuous CSPMs. And this means that we'll find the time intervals when the specific predicates or specific features are violated. For this, we use the flow change from the database. And we also use the back end to retrieve the right condition or the good condition from this database. And we use statistical analysis. We use the CSPM rules to understand how to quickly perform this reverse task, how to bring kind of this flow event to the surface to see which features or conditions are being violated.
Вот если кто-то пользуется, там, не знаю, Cloud Query, например,
Okay, if you use query, for instance, you run some scans and you've got snapshots of the condition at a given moment of time. But the problem is that you don't know what the threat agents did between these snapshots.
S3
Like you have the S3,
стало публичным, потом
which becomes public, and then it stops becoming public, and in between this incident took place. So this is not really nice. So this is a way to make the life of security guys easier. Talking about AI, we have another building block we need here. So we should send this event somewhere, and
Яндекс Облак,
we
то есть таким
Yandex Cloud is just any other cloud, like a customer cloud. Not much difference. We have about 600,000 EPS, so we had to somehow digest all of that, and this resulted in this system. So we have the same principles, and so
вчера Леша
the things we see under the hood. Yesterday, our colleague Lasha talked about this stuff. So if you are interested in this and how it is done, kind of technically, you are welcome to listen to the record. So the main idea is that we had to
первый
right assumptions. Number one, we need to have a good
понятные контексты, понятные
good context, and we should understand the type of data to add AI properly. And then we kind of did this denormalization, so and so on and so forth. So,
AI, потому что с такой
and again, AI is quite good here. It hallucinates less with this approach. And one more final thing to mention.
подумали, что
we kind of thought that, okay, new services get connected, and it should be done in a way that you don't need to renormalize it and to pull it and so on. So we do it through the audit trail, so that all these rules, all the new things should work together.
So the resulting thing looks as follows. There are several acronyms here, and probably you can see it clearly because it's in small font, but these are the small boxes that we can assemble through Yandex Cloud, so you can replicate the scheme. It looks as follows, and if you know Java rules, you can probably recognize some of them. And we apply here the same approach with the flow of events. We move within this window, and within this 10-minute window, we are looking for suspicious actions performed by robots. Where is it applicable? Very often we get asked, how can you guarantee that your engineers will not tamper with data inside the cloud? Well, if an engineer will be assigning some special rights to themselves to fix something, that goes through Bastion host. And then there is another rule with the server that protects us from the situation when someone acts through the account of a robot. So we use these rules to see what happens inside. So how does it function? Here's another example from an investigation. It was during the night time, of course, as usual. It usually happens during night time on Friday. You are tired, but you get an alert and you need to somehow respond to that. So there is this suspicious activity because a weird IP address accesses the cloud and some basic defenses worked, and then you need to somehow support that to block the malicious actor's activity. If the prompt was written well, that can help you in the way that the timeline will be well structured, and you can feed the log to the system. You get this timeline, and from 42 minutes, it keeps completing this path. And you see that there are several backdoors that the malicious actor created for himself, and you know how he's going to act. I work with the cloud for 18 months already, but I still use help with because it's impossible to memorize all these actions. So AI helps a lot. It generates what has to be done to chase the malicious actor from the infrastructure, or to make the malicious actor to repeat the attack and to see what he's going to do. And we also used AI to analyze some defenses, some information protection defenses. And I don't know whether you enjoy reading these logs. I do, because sometimes you get just wonderful things within the same panes. You can see just totally different sets of data, and sometimes you see that this pane is called P1, and you can get different things there. So AI helps a lot there as well. We use Uppermore, and here I think this example is very simple, and you understand what had to be done there. Sometimes situations are more complex, and you first need to read through documents and find the service and to understand what's happening. And then usually the hosts have some legitimate load and some illegitimate load, so you need to distinguish between the two. With AI, it can help you
У тебя есть база
Because,
наработанных
for instance,
ты смотрел
you have a log of
нагрузку, как раз вот эту вот
responses
вот ее там вот
when you were looking through legitimate
мониторинг, да, и
load, and
промпт составлен таким
there is
образом,
this tool that helps you monitor the situation. And the prompt is formulated as follows. First, you check whether it's dangerous or not, and then you look at the probability.
как бы пиды, там еще что-то, все это.
And it does help because it
it
just digs the right information, the data you need.
по часу. Вот. И
And then
саммаризирует, плюс саммаризация вообще это прям
you,
то, что делает аишка,
your shift
умеет вот
ends and the next analyst starts working.
в
So AI does help you with different interfaces, with different networks.
резюме, то есть ты можешь договориться, вот там типичная работа внутреннего сока. Тебе надо не просто
And then
солертить, да? Тебе надо еще
in a typical SOC, you don't only need to
там, о чем ты договариваешься, потом приходит твой коллега, и опять повторяется та же самая.
fine-tune your software. You need to really fix all the bugs. And
Что
your AI can help you there. And for instance, you can
неделя прошла.
ask AI
И второй момент.
to check whether the things that your colleague promised to fix were indeed fixed. And then in every company, there is lots of custom documents, and of course, it's just impossible to memorize all of that. And AI helps you there as well.
Одна проблема, да?
For instance,
AI может тебе подсветить, что еще мы
you know that there is one problem, and then AI can highlight for you that you also need to mark the scheme, and that's how it can be done.
получаешь готовый ответ, и
And some developers actually use AI not to read through all the documents, but to go straight to the point.
которые у нас работали и которые стоят, то
And then
есть строгая типизация точно очень хорошо.
the main
Для плейбуков аишка
important cases that worked well for us, AI works well for playbooks. It's just that you need to check that your temperature was set to 0.
и помогает объяснение то, что
And then
принесло тебе на человеческий язык, неплохо может перевести.
if your
Из того, что
information
сложности, с которыми мы столкнулись,
security system
ошибается больше, чем в трети случаев, то аналитики перестают им пользоваться.
gives you the prompt, you need to make
Надо тюнить.
sure that
Если скармливать,
you interpret it well, and
то можно получать разные процентные
Then,
графики. Это вообще классно.
you can play with AI in terms of
Вы проверяли.
feeding different
по-разному
figures and models
интерпретировать. Вот. Но в целом,
to them, and you'll get different diagrams. So it can be useful.
всё, что показали,
You should
всё можно
test it out.
повторить.
So everything we showed today is repeatable. You don't have to
облаке
install any
улучшать.
special software. It's repeatable in Yandex Cloud. Thanks so much.
Да, Юрий, Владислав, спасибо.
Thank you, Yuri and Vladislav. Guys, do you have any questions?
Спасибо. В общем, вопрос... Слышно, да? Вопрос следующий.
Thank you. The question is as follows. If AI makes a mistake, if it gives you a wrong instruction, how can that be fixed? How can you roll it back and understand the reason of that mistake?
Обычно аналитику дают
Thanks for the question.
3 варианта ответа на выбор.
Usually, an analyst gets 3 options of
Потом
the
он
answer,
тот вариант ответа, который
and usually the analyst picks
таким образом мы потихонечку
the answer and
потом мы эти
likes
анализируем и дотягиваем результаты.
the right answer, and usually we then analyze that and learn from that.
Не в попад, пока не нашли.
And so far, we haven't got
Второго
a
мнения.
single case when AI would suggest something
И аналитики дотягивают.
completely weird.
Да, спасибо.
So usually we use it
Еще вопрос.
as a way of searching for options, and we fine-tune it with human analysts.
Коллеги, спасибо за доклад. У меня, собственно говоря,
Thanks for your presentation. I have 2 questions.
про непрерывный контроль конфигурации.
First, about continuous config control.
Вы храните, ну то есть когда непрерывно,
First,
и как собираете, то есть
what data
каждое изменение состояния
do you
собираете,
store and
и где храните?
what data you collect? Do you collect information about all the changes and where do you store that data?
Какой периодичностью?
And how often, how frequently do you
Первый вопрос.
save
И
that data?
второй
Every
вопрос.
second or what's the
Вы рассказывали
frequency?
про боевое применение.
And question number two, you talked
активов,
about
когда у вас
real-time,
не было айпишника, а на входе
real-life
что было?
use of
Название
assets
виртуалки,
when you didn't
и
have
вы не знали айпишник.
IP addresses, but
Спасибо.
what did you have?
Теперь через тебя.
Was it the address of the virtual machine?
Мы храним внутри базы данных.
Answer number one.
Реляционная база
Usually we
данных,
store data in our database. Usually it's a
Они называются
relative Yandex database, and usually we use the relative
штука. На
interval
самом деле можно
tree
использовать
for
другие
setting the frequency. You can use geo-indexes as well.
Целевое их назначение.
It is not their
То есть мы не
primary purpose, but you can use them for that as well.
снапшот для каждой точки во времени, но
I
мы
mean, we don't save snapshots for every point
выдаст
moment of time, but we can write a request that will generate a snapshot for a certain point of time for us.
Мы знали, какие виртуалки были
And then,
удалены, да,
answer number two,
и в логах были
we knew
то есть нам надо
what
было как раз
virtual machines were deleted, and in our logs we had IP addresses.
надо было понять, а чьи IP
We just
это в тот момент времени.
had to understand who
Например, облачных
were the
систем,
owners of
когда
these IP addresses.
меняться достаточно часто. там,
And in the cloud, IP addresses can be changed quite frequently. It's very easy to get a new one,
другой машинки. И вот это
and they can be changed for every machine.
какие, потому что
So that was
в момент расследования инцидента
actually the difficulty.
того айпишник уже был
When we were investigating that incident, that IP address was already
не до конца
assigned to another machine, and we saw this discrepancy.
были предназначены.
And then, when we rolled it back, we saw what
Еще
these IP addresses were related to. Thank you. Other questions?
Добрый день, меня зовут Крикун Александр.
Hello, my name is Alexander Krikun.
То есть, насколько я понял, ваши сервисы нечто
As far as I understand,
tables.
your service is like IP tables in the network protocol. It controls
Что может ходить?
the status of packages and what can be transferred. Do you use AI that can block something?
Давайте
То
так.
есть в вашем случае всегда человек
I
принимает
mean,
решение.
in your case,
То есть если какие-то уже автоматические
a person, a real person, takes a decision
каких состояний,
about what can be done.
правила и
But
живут
do you use AIs that formulate rules and you just observe how they
До такого не
do
дошли.
that?
И опять
Answer.
же, это
We are not at that level yet, and that's the problem of models hallucinating at some point. It hasn't been fully solved yet,
сходу не
and probably we will not be able to implement that kind of
продакшн.
models because the price of a mistake is production getting down, and in the cloud
вообще это
it's
работает? То есть вы таких экспериментов
less costly. So you haven't experimented with that yet.
В свободной плане
Answer. Well, no, we haven't yet
каких-то тестовых площадках.
allowed AI to be fully autonomous, not even within a testing range.
Да, Юрий, Владислав, спасибо вам еще раз большое.
Thank you, Yuri and Vladislav.
Выберите,
Спасибо.
пожалуйста, лучший вопрос.
Please pick the best question.
тебе нравится? Что? Вот есть.
Да.
Все. Спасибо. Нам больше всего понравился первый вопрос.
We like the first question most.
Все. Не хотят. Так, второй
Okay.
вопрос. Так, где товарищ, который спрашивает?
Then, if you
Вот, все. Да, спасибо.
if you don't need it, we'll give it to
Друзья, давайте еще раз поблагодарим.
the second.